With the data types that we've covered so far, we've gone over some of the operations that we're able to do with them. So with numeric types, like integers, floats, doubles, and longs, we've gone over how to add, subtract, multiply, and divide them. Basically just do arithmetic, which is what you expect to be able to do with numbers. And with characters and strings, we were able to see that we could concatenate them together by simply adding them, which would just append two strings together, or append a character to a string, or vice versa. The last primitive data type that we haven't taken a look at yet would be the Boolean data type. As a refresher, a Boolean data type is simply one that takes on a truth value. That means it can be either true or false, and that's the only two values that it can take on. So a Boolean value is binary in that it only has two results that it can possibly take. If we wanted to create a Boolean variable, all we have to do is give it the name bool, and then a name as per usual, and we can give it either the value true or the value false. And those would be the only two values that we can give it. Now it might seem like there's not a whole lot to this, but we'll see in the next video that this actually has a lot of applications. For the time being, let's just go ahead and take a look at some of the operations that we can do with Booleans and how we can get Booleans out from doing other operations. First things first, let's take a look at some simple logical operations. Here we have the basic logical operations that C++ supports. If you've taken a philosophy course before, then these probably look very familiar. Or if you've taken a math course before, these probably look familiar as well. Now, because they can only take on true and false values, we're limited in the number of outputs that they can possibly give us. Here we have two binary operators, meaning that they take two arguments. So something like plus normally is a binary operator because you can only add two numbers at once, at least with one plus sign, right? I can only do 1 plus 3. If I threw in 1 plus 3 and then put a 4 at the end, then that's not usually clear what that means in math. Here, Boolean operators support two binary operators and one unary operator, meaning that it takes only one argument. The two that we'll be using for binary are and or. And they do kind of work like you would expect them to in English. When I and two Booleans together, the result is only true if both parts of it are true. So if you think in English, if you have something must be true and something else must be true, then the result must also be true as well, right? But if I say that in order for something to be true, A needs to be true and B is false, then your result is false. For instance, if I said the sky is blue and 9 is a letter of the alphabet, then my whole statement is false because yes, the sky is blue, but 9 is not a letter of the alphabet, so my whole statement that I just said is false. That would be this third entry. That would be an example of this third entry in this table, where the first statement is true and the second is false, which means that the and result will be false as well. And the same thing goes for if both of your premises are false, both your Booleans are false. If you and them together, you'll get false. If you were to and in the opposite direction, so false and true, you'll get false. The only way for and to be true is for both parts to be true. In C++, the and operator is done with two ampersands. Make sure you put two. I'll go into what a single ampersand means in a second, but be very careful that you are not using a single ampersand because it does mean a different kind of and. Our second binary operator is or, which is done with these two stovepipes. Again, make sure you're using two of them. If you only use one, then it does mean something different. It's a different kind of or. Or, again, like in English, makes a bit of sense. If we have one of the two things is true, then our result is true. So if we think about it, if A is true or if B is true, then our answer is going to be true. Here we can see in the truth table, if we were to take A or B, where A is false and B is false, that's the only one where it's false. Otherwise, if I was to check if A was true or B was true, then I would get true, and same thing if A was true or B was false, and if A was true or B was true, then we would get a true result. Basically, the shortcut to it is if one or more of your arguments are true, then when you OR them together, you're going to get a true as well. If you're already familiar with logical operations like this, then you might be wondering where EXOR is, and we don't actually support logical EXOR in C++. You will have to do that the long way, which I'll give an example of later. But if you're not familiar with EXOR, then it's the kind of OR that you would expect when you, let's just say, go to a restaurant and they offer you soup or salad. That's a little different than the OR that we have here. Whereas this is an inclusive OR where only one has to be true, and exclusive OR is one where only one can be true, which would mean that this last part would be false. Essentially, it's a way to check if the two things don't match. If we go back to that soup or salad example, if you order soup or salad at a restaurant, the waiter asks you for that, then if you order soup, then that's okay. That would be true. If you order salad, that would be true. If you order none, then you're not really fulfilling the waiter's question. And if you order both, then you're probably going to make the chef angry. So if you don't order anything, or if you try to order both soup and salad at the same time, then those would be our two false examples, because they're not what's expected of you at a restaurant, let's just say. The last major operator that we have for Booleans is called not. And unlike the other two, where it works on two operands, where this one was A and B, and A or B for my two examples, this one here only works on one. And again, kind of like in English, it makes a bit of sense here, which would be not. Not is done with an exclamation point, and it simply flips true to false and false to true. If we think about it, if something is not false, it must be true. And if something is not true, it must be false. Lastly, I'll do a quick example here just so you're familiar with it, but no, we won't use this example in the actual course itself, which would be the bitwise logic. These previous ones were logical operators. These ones will be bitwise, and what that means is that they, instead of operating on strictly Booleans, they will operate on the bits that make up your variable. So if I was to, let's just say, have a byte, which is not a real data type in C++, it's called a character, but just for the example, a byte that is 000111100, and I had a second byte that was 10011010. If I was to use the single ampersand, then that will do a bitwise AND, which means that it will look at all of the bits that make up a byte, which are these little ones and zeros that we have here, and it will AND each of these together. Remember that an AND only works if both things are true, is the only case where it will give you something true. So this one, being 0 and 1, has a 0 in it, which means that our result will be 0. This one will be 0. This one will be 0. But this one will be 1 because a 1 and a 1 is the only way to get out a 1, when you're using AND at least. If we took 1 and 1 again, we would get 1. 1 and 0 is 0. 0 and 1 is 0. And 0 and 0 is 0. Don't worry about this too much for this course. It's mostly just something I wanted to go over because it is an operation in C++ that it supports, and if you're already familiar with binary, then this might be able to help you in the future. But the other reason I mentioned this is because this is what the single operands do. So if you have just one single ampersand, this guy, or if you have one single stovepipe, or you use this, the up caret, which is EXOR, it's a bitwise EXOR, then you will get it to do a binary result, and you might notice some weird stuff if you try to treat it as a Boolean, rather than if you did the previous example here where we have the two ampersands, the two stovepipes, or the exclamation points. Well, the exclamation point we can't really do a bitwise not one. It's not, at least it's not the same character. It would be a tilde instead of a exclamation point. Anyways, let's do a few examples of these in the actual code, and then we'll do a few more operations that will help us. Okay, we're back to coding in C++. Let's do a few examples of booleans and how we can do operations on them. Here I've created two boolean variables, one called flag t and one called flag f. And what I'm going to do is just simply show that some of those values in that truth table that we did earlier do happen to work in C++, and then we'll use the operators. Here, first off, let's do cout, and then I'm just going to put parentheses just to be safe, flag t or flag f, and then I'm going to copy this and do it with and as well. And let's print out a little message just so this is easier to see. So true or false is equal to, and then we'll do the same thing down here, and we'll just use and instead. Right, and so if you were to guess what this does, you can take a moment. If we want this to be true or false, then remember that or works as long as one of the two parts is true. And if we wanted and to work, then it's true only if both of the parts are true. Let's run it and just double check what this actually ends up being. Okay, and it's opened up a terminal, and if we look at it, we get that true or false is 1 and true and false is 0. When it prints in C++, it does seem to give 1 and 0 instead of a true or a false word, but that's okay. 1 is true and 0 is false. And hopefully this is what you predicted, because if it's true or false, then only one part needs to be true, so we expect our answer to be true. And if we wanted it to be true and false, then that's going to be false, which is a 0, because both parts have to be true in order for and to be true. So if I wanted this second part to be true, let's just say, I would need to add true flag with itself. And you'll see that we have it there. Now let's do an example really quick with a more detailed version of a Boolean expression. And so let's try to simulate EXOR. EXOR means that it can only be true if one of the two things is true, but both can't be true, and if they're both false, it's also false. This means that there's only two examples where this works, so the common way to break this down is to simply say that if A is true and B is false, or if B is true and A is false, then this will work. Really quick, let's try to write that down. And so what we want to simulate is the equivalent in logic of saying EXOR, which is normally done with that, or with, actually, I'll just say just normally that. A, EXOR B. What this means is that either A is true or B is true, but not both. And we don't have an operation to be able to do this in C++, at least not on a logical level, so let's try to do an example and come up with that only in terms of and or. If we think about it, then false should give us a false, false EXOR true should give us a true, true EXOR false should give us a true as well because it has one true part, and true EXOR true would be false. And these would be the only four examples, right? I need to do all four combinations, and one way I can do that is simply to count it out like it would be in binary. Let's try to simulate this by simply looking at only the two examples where things are true. I think this is the best way to work out logical operations like this if you need to find a solution. So we see here that it works when only these two are true. That means that we either want A to be false and B to be true, or we want A to be true and B to be false. Here, that would mean that we are going to either have not A and B. So this would be that one, because A is not true, but B is. And the other example here that we have would be when A is true and B is not true. So we'll put a exclamation point, not B. Now, we want any of these to be true, right? And if we think about it, OR is a way to represent if only one thing or more are true, then your result is true. So the way we can do EXOR in logic is to look at these ands that we have. This is true when A is not true and B is true, and this one is true when A is true and B is not true, and we'll simply OR them together. So if I wanted to finish writing an expression for this, I'm simply going to take this one and this one, and I'm just going to OR them together. So here we'll get not A and B, or, so I'm going to put parentheses around these just so that they go in the correct operation order, A and not B. Right, so this would be the second one, and this would be the first one. Right, that's this one, and that one's that one. And so this is how we write EXOR in C++. It's a more complicated example, but hopefully it gets the point across that we can represent a lot of different logical things using just the AND, OR, and NOT operators. One other thing to note is that because these are operations, they also have an order of operations or a precedence that they go in. So whereas with arithmetic operators, which you're used to probably from your grade school math, where we have, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction, we also have something here where this goes in order as well. And the order it goes in is first not, and then OR. So not always comes first, and always comes second, and OR always comes last. That being said, I could get away with not doing parentheses in this example because it does this order of operations, but I would like to put parentheses there just to make it easier to read. So I think that about covers the actual Boolean operations where we have one Boolean and a second Boolean and we're able to do them together. Let's quickly type this up and just test it, and then we'll move into the last example of Booleans. Here I'm going to maybe rename this to be Boolean A and Boolean B. This way we can see some things here. And we're simply going to write out the code that we just did. So we'll say if we wanted to do EXOR, it would be A and not B, or and I'm using lowercase here, but I use capital. So let's change that to a capital. A and not B, or not A and B would be how I write this in C++. Right, so let's go in order. Let's first start with both to be false, which would be 0, 0. And if we run that, we should see that we will get a 0, right? Which lines up with what we had in our notes here. We had that false, EXOR false, was false. So if we do false for A and true for B, and then true for A and false for B, we should see that we'll get some trues here. Really quick, let's do a true for that one. And we should hopefully see that we'll get a true in our output, which we do. So if one part is true and the other is false, we expect it to be true in the answer. Vice versa, if the first part is true and the second part is false, we expect it to work. And we get a 1, which means true. And then lastly, if we want both parts to be true, then we should get a false because in EXOR they can't match. And we get a 0. So this correctly simulates EXOR because it does all 4 things in the truth value correctly. Don't worry about this too much. If you haven't taken a logic course before, you might in the future, and this will go into further detail. This is just kind of an example for how we can do these in C++. Now we've gone over actually being able to do Boolean operations, that is taking 2 Booleans and getting a Boolean out. We also want to do some common ones that correspond to just normal math operations that return Booleans. So the ones that those would be in math would be equal, not equal to, greater than, less than, greater than or equal to, and less than or equal to. And we can do all of those in C++. Here, as an example, let's simply make int x, and we'll set it equal to 3. Now remember that in C++, the equal operator means assignment. So this line specifically creates a variable called x and sets it equal to 3. It doesn't do any sort of checks where it says, is x equal to 3? It's not so much a question as it is a demand, is the way that I usually think about it. But if we want that question kind of way of doing it, is this equal to 3? What we can do is use a different kind of operator, which is equals equals. So here I will do a cout x equals equals 3. And what this will do is it should return true. So this is a comparison operator is what it's called. And it compares whether the two things are true. In this case, we should get it to return true because x is in fact equal to 3. You'll see that we get a 1. If I wanted to do it with 2 variables, let's just say I made it int y and set it equal to 4. If I was to check is x equal to y, you'll see that we won't get a true because 3 is not equal to 4. So this one would be the 0 there. Perhaps let's throw a string in here so that it's easier to read. So XOR equals, and we'll maybe throw in A and B here just to make this work out better. Identifier A, oh, that's because it's not capitalized. B, and then I'll throw an equal in here. And then in this one, we'll put is x equal to y. So again, the way I usually think about it is it's like a question when you use these 2 equals. It should give you a true or false answer back. Notice that we go from having 2 integers or 2 numeric types and we end up converting to a Boolean as our output, which means that we can convert in some way from doing an integer operation or a float operation, because this works on floats too, to a Boolean answer. And so we see that 1 XOR 1 was 0 and is x equal to y 0, which we expected because 3 is not equal to 4. Now if I was to just test one last time, let's say if I made y equal 3, then we do expect these to be the same. So let's just make sure that this prints true, and we'll see that it in fact does. So x is equal to y because they're both 3. Lastly, let's go over the other remaining operators that there are. So the remaining ones would be less than or equal to, greater than or equal to, less than, and not equal to. So here we'll do a not equal to. Like with the normal not that we did before where it was unary and you simply put it in front of something to make it a not, here we can put it in front of the equal to. So if you put a exclamation point and then an equal, that is not equal to y. So this would be our not equal operator. And then we'll do 2 here. So we have a greater than operator, we have a less than operator, and we have the less than or equal to and greater than or equal to versions as well. So I'll just copy this twice, which would be simply the less than sign and then the greater than sign with an equal. Let's do this the other way. And these would be all of our comparison operators that we have. So this one is greater than because it says that the left is greater than the right. This one would be less than. This one would be greater than or equal to. And this one would be less than or equal to. And I'm simply going to make this, let's just say, -1. This works not only on integers, but it works between integers and floats. It works on just floats and generals, and it will also work with booleans as well as with characters and strings, and it also works with some other types that we haven't gone into yet, but they work in a bit of a different way, which you'll learn more about if you take CS 202. Anyways, let's go ahead and finish typing this out, just so we can check that these are all true or false. We should see that about half of them are true and about half of them are false here. We'll go ahead and run it with x equal to 3 and y equal to -1, just as a reminder. And we see that is x equal to y? Well, no, because one is -1 and one is 3. Is x not equal to y? Well, that's true because they're definitely not the same number. Is x greater than y? It is, because 3 is bigger than -1. Is x less than y? No, because it is 3, and that's not less than -1. And is x greater than or equal to y? Yes, it is, because it's already greater than it, and it's not, well, it is not equal to it, but if it was, it would also work. And then we have a less than or equal to, which is a 0. And there we have it. We can use these math operations to be able to check things like that. Let's do one quick, more practical example of this, and then we'll finish off for the day. So let's go ahead and do an example where we check if a number is between, let's just say, 2 and 7. We'll say, is a number on the domain 2 to 7, where this is an open brace and this is a closed brace. On the number line, that would look something like this, right? Where we have a 2 and we have a 7, and the 7 would be a closed circle and this one would be an open circle, right? If you remember from your math, one way to do this was to use less than and greater than, and then also to be able to joint them together. So here we could break this down into two separate lines, where the first one, let's just say, is 2, and it goes like this, right? And then we have another one where it's 7, and then it's a closed dot, and it goes like that, right? And the result here, this region where it's 2 to 7, is kind of like where they overlap, right? Where this 2 line, this green one, overlaps with this blue line. That is our answer, the domain 2 to 7, or the range 2 to 7. So let's break this down. We know that this one, if we look at it, is going to be, let's just say that the number is greater than 2. Here, let's just use a variable called int n. That way we can distinguish this from the x and the y that we did previously. So this one would be simply n is greater than 2, right? No equal to, because it's a open circle. And this other one would be n is less than or equal to 7, because that would be a closed circle, and then it's going to the left, so we know that it's 7. Now if we want these to be an intersection, again, if you're familiar with math, you might already know where I'm going, then an intersection is the word and. If we want this to be true, then this both needs to be greater than 2 and less than 7 in order to be between 2 and 7. Which means that we can use our operator that we have previously called AND, which is the double ampersand. Let's go ahead and try to code this really quick, and then we'll just test it with maybe 2 or 3 numbers, and we should see that it works. Here I'm going to just write a comment that says checks if a number is in the range 2 to 7. So between 2 and 7, inclusive on 7. Right, and so I will just create a variable called int n. Let's actually make it a double, just for practice. So we'll say double n. If you, again, are a math major or you know something about math, you might be bothered with my variable names because n is usually something for integers and x and y are usually for floats. But don't worry about it too much. We like to break rules here in this class. We'll just say 10.4 for now. And we will simply see out is n between 2 and 7. Or well, let's just say in 2, 7, like that. Right? So if we want to check that, we simply said we need to check if it's greater than 2. So we'll check is n greater than 2. Again, I like to put spaces in between these operations, but you don't have to. So we have n is greater than 2, and n is less than or equal to 7 would be how we write this. And then I'll put an end line. In fact, let's put an end line here at the beginning just to give us some breathing room. So here we expect our answer to be 0 because 10.4 is not between 2 and 7. We will run it just to check, make sure that that is true, or rather false. Make sure that our program is true, but the answer is false, which we expect. And let's say we pick a number between 2 and 7, like 3.6. Then if we save it and run it again, we should see that this time exports 1, which is true. And then lastly, let's make sure it works with a number less than 2, so let's just say -4. And if we run it, we should get false because it's not in that domain. And in fact, we do. We get a 0. So that seems to correctly simulate checking if a number is between 2 and 7, where 7 is exclusive. Anyways, that's just a few examples of how to do Boolean operators, whether it be between two Booleans or getting a Boolean out from using other things. In the next video, we're going to actually expand upon this by using these Boolean operations to do some checks and then be able to use the result to do more interesting things.